Okay.
Butane lab.
So we're going to go ahead and take the lighter and dip it in the water, because we want to try to have duplicate conditions between each trial. You're going to dry it off real good with a paper towel. You're even going to shake it out. You want to try to put some air through it. Sorry.
That's okay.
We're going to try to get all that water out of that lighter. Go ahead and tear. And go ahead and mask the lighter. So while that's masked, you're going to put that in your data table. And in the meantime, one of your partners is going to fill a 250 milliliter graduated cylinder full of water. Now, the whole idea is to make sure that there is no air in the graduated cylinder, none whatsoever. So what we recommend is that you hold the graduated cylinder over the water. Take another beaker of regular water and just pour until that surface tension creates a bubble. You see how it's bubbled? And then this is the tricky part. You're going to stick your hand on there as tight as you possibly can, letting no air in, and you're going to flip. And I messed up. See? Notice the bubble of air. You don't want that bubble of air. Now, I'm not going to do it again, but you would have to try over and over again until you have no bubble of air in the top there. Then I go back and take my butane lighter, and I'm going to lift this and stick the lighter underneath the water so that all the gas is going to go into the graduated cylinder, displacing the water. So as you'll see when I push down on the red lighter button, it lets gas out. As the gas comes out, it's pushing the water out. This is what we call water displacement.
Two people can be doing this, and the water might be so cold that you have people switch off who's putting their hand under the water to fill.
Now for you, your procedure tells you to gather as much gas as possible, leaving 5 milliliters at the very end of the graduated cylinder. So say I had a 250 milliliter graduated cylinder, then I would fill it with 245 milliliters of gas. But for time's sake, I'm going to stop right now. So, we've collected our gas. You need to read the volume of the gas that you've collected. And really you can look upside down. If this is 0 at the bottom, I can still move down and check this out, and it looks like about 40, maybe 41 milliliters, 41.0 milliliters. See, I can only guess one digit past the 10th spot on this, and so that would be 40. I'd say roughly 41 milliliters of gas.
Now, in of course the ideal situation, your amount of volume of gas would be below the surface of the water. So you want the surface, the level of the water inside the graduated cylinder and the level in the bucket to be at the same level when you take this reading. So it could be difficult to read. So you want the water inside the bucket to come up as high as possible so it'd be easy to read that. The reason being the weight of the water pulling down might give you an artificially low volume when you are reading the graduated cylinder.
Good. So we're taking that volume, and now after you've taken the volume of gas that you've collected, it's totally okay to just go ahead and lean that graduated cylinder inside. And now we use the same procedure with the lighter. Gonna dry it off real nice. Water is actually a pretty heavy material, and so it can add a lot of air to our measurements. And you're gonna shake it off again.
Hey, how's it going?
Dry it off some more. And mass again.
And as you can see from the mass, Mr. Underwood did a great job of getting all the water out. The initial mass that we had was 19.66 for the lighter. We took it released the gas into the graduated cylinder, and now we're at 19.64 or so. And we, of course, would lose mass because gas was released from the lighter. And if we were to, that was only 40 milliliters of gas, so maybe times 6 to get to about 240 means that we'll have somewhere in the neighborhood of 0.12 grams. That's not very many grams. It's a low mass, so that's why we're collecting such a large volume.